Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today. We have a really interesting show today. We have some soil and we have the 12 birds of Christmas.
I'm very excited to have DJ McNeil with us, as well as Dr. Amanda Gumbert. And it's going to be a great show. Thank you all for being with us. We'll let you know we are undergoing a little bit of technical difficulties here, but we're going to make the most of today's show.
Which is why I'm in your office.
Yes, yeah. So we had to relocate at the last second there, but that's okay. We're glad to have you all with us. We really are, and I'm really excited about both our guests. If you all have questions for either of our guests, you can use the chat function and interact with them that way. If you're a YouTube viewer or a podcast listener, you can hit us up via email at forestry.extension@uky.edu, and we can respond that way. And we'd love to hear from you. We'd get some responses pretty regular. So so let us know what y'all would like to hear about, or if you had questions about either one of our presenters, and we'll try to get those addressed for you. But I'm glad to be here with you today.
So let's go ahead and get started. So Amanda, if you'd like to turn your camera on.
In case you need to be convinced about the wonder and amazement of soil, that's why I'm here today. So I'm Amanda Gumbert. I know I've been on the show before, and I appreciate the opportunity to be back. And I'm a water quality extension specialist in the Forestry and Natural Resources Department. And but I have a background in soils and a strange fascination with them, maybe. So we're going to talk a little bit about soils today. And I always like to start my soil talks with like a real basic question of what is soil? And many of you probably have thoughts on what soil is and what's in soil and all that kind of thing. But I always like to start with this little pie chart, and it's kind of across the world, a generalization of the four main components of soil. The biggest portion of soil, which is what we usually see and can touch and feel, is the mineral component, and that's about 45% of our soils. And then that little sliver of the pie, the OM, is organic material or organic matter. And that's represented in this picture of that. If you look closely, there's some red worms in that soil sample there. And so the organic material, that includes the roots, that includes any kind of fauna and flora that are there in the soil. Much of it we can't really see with the naked eye, but some of it we can. And then the remaining 50% is equally split, or proportionally split, I should say, between air and water. So if we have saturated soils, then it would be closer to 50% water and not much air there. And then if we have really dry soils, we would have much more air than we would have water. And so those are the four main things that make up our soils in general. Like that's a broad brush of generality. And so, what's the hype about soil? I like to walk around and say, soil is the most important resource we have. But, isn't it just dirt? I get that comment a lot. And I always like to say that the difference between soil and dirt is misplaced soil. Dirt's what you track in the house on your shoes and you get in trouble for leaving along the way. Soil is in its place, doing its thing and functioning in the ecosystem. So the Soil Science Society of America, of course, there is a society, and the Global Soil Partnership and the International Union of Soil Scientists, I mean, could there be more exciting organizations to join, declared 2015 to 2024, so we're finishing up the International Decade of Soils that was kicked off in 2015 with the International Year of Soils. So lots of education was put out by these organizations about soils. But as Renee mentioned earlier, tomorrow is World Soil Day. And so this is part of an international celebration of soil and really about measuring, monitoring, and managing our soils. So that is part of what we're interested in, especially as a scientist. We're interested in learning how soils function and what how they change over time. And we do that by measuring and monitoring different aspects of soil. So this is where you can really dig into the details of soil. Do you like what I did there? So when we think about soil components and soil characteristics, I think of all of these in this image. I think about particle size, I think about organic matter, structure. We're going to talk a little bit about all of these in a second. Color, horizons, those are the soil layers. Think about pH. That's usually one that we think of when we interact with soils, either in growing food and fiber, whether that's on a big scale in our forested landscapes or in a smaller scale in our backyard gardens. The pH is one thing we typically think a lot about. Ion exchange, that's the chemistry part of soil. Water holding capacity, again, remember we talked about that air water relationship. That's where water holding capacity comes in. So all of these components are individual characteristics of our soils. And together, these soil characteristics help provide ecosystem services. And we talk about ecosystem services in a wide variety of components and aspects on this show. But from a soil perspective, soils are supporting all of these that are itemized here. We produce food, we produce biomass. Um, Nitrogen, our nitrogen cycle, which is we could do a whole show in and of itself of the nitrogen cycle, and how soils play a role in transformation of nitrogen throughout the ecosystem. Soil carbon storage, that was some work I did as a master's student out at Robinson Forest, looking at soil respiration. Soils breathe, they exhale, and they exhale carbon dioxide. And so that soil carbon storage in the soil. We're learning more and more about that every day. We still don't have a good handle on the exact well, with some of the mechanisms we know, but the exact quantity and really putting numbers to that is really tricky. So, but soils are a really big part of the global carbon cycle. And when we think about climate issues, that's an important piece. Infiltration and water storage, what kind of structure or infiltration capacity is at the surface of our soils, and what does that mean for water storage in the soil itself, but also groundwater recharge? So there's that soil water relationship again. I think you can see why, like, it's really hard to separate those two. Erosion control, how we manage the surface of our soil is going to influence erosion and erosion control, probability, et cetera. Microbial faunal colonization. I'm sure most people talk about that around the dinner table. But that's something, again, when we're talking about all of the biological activity, there's a lot of activity going on in the soil. Those microbes are impacting the carbon that is being released from the soil. All kinds of interesting things going on there. Weed and pest suppression, beneficial insect conservation, wildlife habitat. I mean, the list just goes on and on and on. So hopefully, like I could probably stop here and maybe you'd be convinced that soils are really important, but I won't. I'll keep going. So what I like to do when I talk about some of the basics about soils is break these down into physical, chemical, and biological characteristics. And then we'll kind of wrap up toward the end with some where to go for more information on these things. So when we think about physical characteristics, I always start with where a soil is in the landscape. And this is just a little graphic of a generic hill slope. And, so when we, and not, of course, we know that, not every landscape looks like this, but in general, we have to kind of generalize. Um, we start at the top of the hill as the summit, and then the shoulder, the back slope, toe slope as we go down the slope. And then at the bottom of the slope, we start to get into the floodplain, maybe an old stream terrace, and then the actual stream or water body that or the lowest part of the landscape at the end. And where our soils are situated in this landscape are going to influence lots of different things, predominantly how deep our soil is before we get into bedrock or that what we call parent material, that material that is the start of the soil formation. Now, a geologist would tell you that geology is the basis of everything. Soil scientist is going to, argue for the weathered geology in the soil. But where we are on the landscape is really going to impact how susceptible our soil is to erosion, whether there's organic material that is accumulating there or whether it's being eroded away, all that kind of thing. Within our floodplain and toe slope area, how much deposition of material are we getting from the stream and from flooding and from flood events? Those alluvial areas, or the areas influenced by water, those soils are going to be a lot different than those up on the summit that are really influenced more by their parent material that's already there and precipitation that's happening. So we talked about a characteristic being horizons. So these are the soil layers, and you're probably familiar with seeing this. I'm one of those nerdy people that as I drive down the road, I'm looking at road cuts and new construction and seeing if I can see a really cool soil profile. So the profile is the picture of the horizons there on that right picture. And the horizons are they're divided. There's these layers. And so at the very top, we would have an O horizon. And in our woodlands, we're going to have, most likely, we're going to have an O horizon. But in Kentucky, that's the most likely place to have an O horizon. O means organic or organic matter, and it's where that accumulation of organic material is. It makes our soils darker at the surface. Um, but we typically, if we have plowed a or disturbed a soil in any way, it's hard to reform that O horizon. So that's why our woodlands that have not been disturbed for longer periods of time will have that accumulation of organic material there on the surface. Then we and soil scientists, are not exactly super creative with our naming, so we just go ABC below that. And so A horizon, that's where we have a little more mixing of our mineral soil and our organic material. Then our B horizons are the subsoil or mineral soil. And then C horizons is where we're getting very similar to the parent material. And that's how our soils are forming. They're forming from the parent material kind of upward. So structure is basically the arrangement of how soil particles stick together to form aggregates. And this is important because it impacts how water infiltrates. And so the soil samples that are here in these containers, they have broken naturally into these aggregates or clods. We might call those clods, and that will influence how water moves through that soil. So these are just some graphics kind of zoomed in on what that looks like. And you can imagine, like, especially that massive or platy, those two images there on the bottom right-hand side, it's a little harder for water to move through those soils and around those soil particles, where the granular and aggregated or the blocky structures make it easier for water to move and for roots to move. So remember, any place that water is going and can move through around particles, our roots are going to follow some of those to try to access the water. Particle size, distribution is what means texture. So sometimes especially in Kentucky, everybody says, well, I've got clay soils. Well, you probably do. You probably do have a lot of clay in your soils because we have limestone parent material, especially in the central and eastern part of the state. And so we have a lot of limestone that weathers into more of our clay particle sizes, and that influences the dominant structure and texture of our soils. So again, how those particles are arranged influence how water moves and how air moves through the soil. I like to show this image because this is a really easy way for you to look at all three particle sizes at home. If you have a jar, mason jar is fine. You put about a half a cup of soil in that mason jar and a tiny, tiny, tiny little drop of dish detergent, and then fill it the rest of the way with water. Shake it up for a while, and then as the particles settle out, sand will settle first because it's the biggest, the heaviest particle, then silt and clay. And it will take your clay particles a while to settle out. And so it's a nice way to see how much you have of each one in your soil sample. So color is another characteristic of soils, and I think it's the most fascinating characteristic to see the different colors of soils that occur worldwide. And these soil colors are mostly reflecting mineralogy. So what are the minerals that are in the rocks that have weathered to form the soil? There's a reflection of chemistry. Also, is it a wet soil? Is it a dry soil? If it's wet and dry and it's alternating that, we can have some redoxymorphic reactions. So that's really going back to your chemistry classes. That's when we have oxidation and reduction. One that we're familiar with is when there's iron present in a soil, we would have more of a reddish or orangey color when it's oxidized, and then we would have gray when it's reduced. And so that means in a wet soil, you might have gray conditions. In a drier soil, you might have that reddish orange color if you have iron in your soils. So, soil scientists use a Munsell soil color chart to determine soil color. And the reason we do this is because soil color, like any color, can be a real qualitative characteristic. And it's hard to communicate among scientists, among researchers, about what the color actually is. So we use a Munsell soil color chart that looks a lot like paint chips and color chips that you would get at the paint store. We use that because we can translate that to a number, and then it becomes a quantitative value to describe a qualitative characteristic. So one that you might have recently seen is maybe this subject. I always love soil scientist humor is really terrible, but I always think this is fun as a way to show the fun that a soil scientist can have with a Munsell soil color chart. So I mentioned that soil color can change based on um, water and water content and different characteristics. And so this is an example of soils that are in different locations on the landscape. So remember, we saw that landscape continuum, we saw that hillside, and we saw those different positions on there. And these are different colors that would be representative of these different areas. So if we start on the left side, you'll see that drainage way is very dark and gray, almost black, because it's probably had saturated conditions. And so that saturation, remember I mentioned this, is causing some chemical reactions with the minerals that are present in the soil. And so the toe slope you can kind of see as you gradually go to the right of the screen, you're going to get higher up on the hill slope, and the shoulder and summit positions will be more what we might think of as oxidized conditions, soils that have iron in them that are not wet or saturated. So we're going to touch briefly on chemical characteristics because I don't want to bombard you with too much chemistry this morning. But I mentioned soil pH, and I show you this graphic because this is where people are really interested and want to know more about soil pH, is what it does to their soil, and do they need to add lime, and do they need to add this or add that, or what's going to happen if their soil pH is off. And when you send a soil sample to the soil testing lab, which we operate through our cooperative extension service, you can take soil samples to your local extension office, and our agents will help you process through um, those samples. They'll send them to UK's analytical lab. And I think we do a really great job in getting those processed pretty quickly and a very good rate as well. But one of the things that you'll see is soil pH measurement. And what I want you to see is where there's green bars on this graphic, that's where those chemicals or those nutrients, macronutrients at the top, those are the big nutrients. So nitrogen, phosphorus, potassium are the big three. And then our micronutrients are in the lower part. Where those little strips are green, that means that that is available to the plant, tree, what have you, to take up at that pH. So if you notice, if you remember your chemistry, 7 is neutral on the pH scale. And we like to shoot for around 7 in our pH or hovering around neutral. In Kentucky, will be a little more basic or higher pH because of all that calcium carbonate that's in our soils from our limestone parent material, our limestone bedrock. And so we'll see that a lot of nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, a lot of that is available hovering around that 7 on the pH scale. So, a little bit about biology. Um, this is probably my favorite part because I think it's so fascinating. We have this enormous food web that's in the soil. It's based in the soil, and it's based also on the above ground ecosystem and how the plants that are growing above ground are supported by roots that are in the soil, and then those roots are starting to break down, and the leaves and other material that drops to the surface of the soil is breaking down and really supporting all of those different elements of the food web, the fungi, the bacteria, um, the nematodes, all those things. Again, some really great conversation material for the dinner table. But thinking about, I mean, mycorrhizal fungi, amazing stuff, and how mycorrhizal fungi is connecting underground. It's connecting our trees to each other. We have evidence now of trees being able to send signals, and they're using mycorrhizal fungi networks to do some of that. And so, without our soils and without a healthy soil ecosystem, those systems might not operate quite as smoothly. And then those small organisms supporting the larger organisms, and then even higher organisms like mammals, small mammals that are burrowing, and all of the different tunnels that they're producing and contributing into the soil as well. Also helping with infiltration, carbon turnover. I mean, the whole system. So, a little bit about soil forming factors or how soils are formed. As a student in intro soils classes, we learn all these little acronyms and ways to remember the soil forming factors. There are 5 of them, and we learned this with CLORPT. And so those stand for climate, organisms, relief, which is also just topography and slope, parent material, and time. And those are the factors that influence soil formation. That's just what you need to know. Um, with climate, we know from lots of information that we have available to us, um, kind of what our climate looks like in Kentucky and our precipitation. So that climate piece, it means what's the freeze thaw action? What are those temperatures doing throughout the year? Right now, as much as we're kind of chilly in Kentucky, those freezing incidences and having frozen soil helps to break apart places where we might have compaction. So um, that freeze thaw cycle can be really important. It can also make our soils vulnerable when we're going back and forth between freeze thaw. So anyway, climate is an influence, especially how much rainfall we're getting. Organisms, hopefully I've convinced you the importance of organisms and how they are breaking down soil, and also how organisms are helping cycle nutrients through the system, and how they influence the chemistry. We didn't even get into that, but that's for another day. Relief or topography, where are you on the slope? Are you at the summit, the back slope, the toe slope? How is that elevation position influencing erosion and movement of larger material down the slope? Are you on a northeast or southwest facing slope? We know in our own woodlands and our own landscapes that those different slope aspects will be reflected in the production of our plants in our trees on those slopes. So, our northeast facing slopes might be much more productive because they're going to be moister. There's no shortage of moisture for our trees growing there. Our southwest facing slopes going to be a little bit drier. We're going to see that reflected too in some cases in the species difference as well. Slope curvature. Are you in a concave where you might be collecting organic material or water, or are you in a convex position in your slope curvature? All those things are going to influence soil formation. Parent material is another thing. I remember I talked about geology, and here's my nod to geologists. But this is a generalized geologic map of Kentucky. So I don't want you to worry about what all it says. I want you to just look at the colors and look at the patterns and notice that darker blue in the eastern half of Kentucky, kind of the lavender purplish color around the bluegrass area. And then as we go to the west and south central Kentucky, the lighter blue, and then out farther west, yellow and orange. And I want you to see how this pattern reflects in this generalized soil map of Kentucky. So I'll go back. There's geology and there's the soils. No shock whatsoever, right? That's our parent material at work. And then I'm going to show you one more map, and it's a little bit small, but this is the green. These are the natural regions of Kentucky that are reflected in our plants and our trees, especially. And so noticing how those same patterns show up hopefully will convince you that our soils are influenced by geology and our plants are influenced by soils, and everything's connected, and it all kind of pulls together to reflect in our species that we're seeing in those areas of Kentucky and what kind of ecosystems they're supporting. The final factor is time. How long does it take to produce soil and for soils to develop? And what happens in these major disturbances? And this is something that we're still learning about. Our own Chris Barton had some research at Robinson and in Eastern Kentucky where they saw soil formation in a much shorter time period than they originally thought. We used to say that an inch of soil took 100 years to form. And now we're like, maybe it's not quite that long. But what happens when you have a disturbance? Those are all factors to consider. So I'm going to wrap it up here with a few tools that you might be interested in. This is your trivia piece for the day. We have an official state soil, just like we have a state bird and a state flower and a state small mammal and a state all kinds of things. The Kreider soil series is on this map of Kentucky. It's the darker red color scattered throughout the West. It's a very important soil for agricultural production, but I think it doesn't get as much airtime as all the other state emblems. So yay for the Kreider state soil. If you want to learn more about your soils, I highly recommend the Web Soil Survey, and you can just Google Web Soil Survey. It's a USDA Natural Resources Conservation Service tool, free for all of us. It pulls data from a variety of databases, but you can pick out your own address and look at your soil. And if you really want a quick access to soil wherever you happen to be, you can get an app for that. And USDA also has the Soil Web app. And when you click on it on your smartphone, you can see the soil profile of where you are standing right there and then. So if you have more questions about soil, I'd be happy to answer them and just encourage you to go out and dig into some soils and learn as much as you can about them because hopefully you're convinced that they're really cool.
Yeah,
That was
I
cool.
loved it. Yes, thank you. We really
Yeah, you're
appreciate
welcome.
it. Nice.
You
Yeah.
covered so much ground in like
Literally.
25 minutes.
I love it. I love what you do. Yeah, yeah. We're on it today with the
Apparently, yeah.
soil trivia.
Hey, if you need your puns, come to the right place, right?
Exactly.
You got it. You got it.
No, Dr. Gumber, thank you. Yeah,
Yes.
and you've almost convinced me. You know, I always say that trees are the answer.
No matter what the
You
question.
might have to start with soil, Billy. You just
You
might have to start with soil.
Get close. Yeah, it's hard.
Say trees and soil
Yeah,
are
maybe
part
nice.
of the answer.
No, it was really good though, and it is so important that we think about those things. And you know, Renee and I were sitting here talking as you were going, and you know, a lot of people just don't realize how complex and how much there is to soil and what all's
Yeah.
going on underground and just those processes and yeah,
That one graphic you had, with the mole and the worms and all that, I was like, yeah, I never
a whole
knew-
world
yeah,
under
there's
there.
a
Yeah.
whole world underneath the soil that people don't pay attention to. I mean, what we see, there's a whole new world going down underneath
I was
there.
going to say unless it's on our phone, but
Well-
now Dr. Gumber.
Now it's on your phone.
Wow,
Yeah,
that's
there's a
good.
couple of
Questions,
questions in the chat pod that we need to address.
One was
Uh,
about organic matter. And let's see. Yeah, how to build
Okay.
up organic
Yeah,
matter.
soil organic matter is always a topic that people like to talk about. So the question is, how important is it to build soil organic matter? So I think it's really, really important. Let me start with that question. Um, I think it's super important because it helps the organic matter is supporting lots of chemical reactions and nutrient cycling that's going on in the soil. It's bringing in that live component that's going to I kind of think of it almost like an enzyme would, kind of speed
Mhm.
stuff up in a soil, but it's really important to have that there also for infiltration. And so what I think about is, we think about how we get rainfall. And if we get really heavy rainfall, soil organic matter can help infiltrate the organic or the rain. It can help reduce erosion because it's also like, look at this, the picture behind me. You can see the roots coming down from those grasses in this particular picture, and having those roots are holding soil in place. But also remember that fungal network that's in there. That's also structurally significant too. So there's so many different elements that soil organic matter supports that I just think it's super important. And I want to go back to the first question: is it better to bury organic material, or is it better to surface compost and work into the soil later? I would say surface compost and work into the soil later. I mean, and that's thinking about from a kind of a backyard gardening management sort of perspective. Mostly because if you're going to surface compost, you're likely to, or more likely to heat your compost up to kill any weed or pest, um, residues, and so that you're not like just burying that. And the other thing is when you bury things, it's also not exposed to air as much. And so it's a different set of microbes that will start to break that down. And some of them are not as fast. They're slower, I guess. So aerobic decomposition is often a little faster. That's why in wetlands, when we have wetlands, and I love to pull a soil sample in wetlands, there's so like it's all organic matter because it's saturated. And so those anaerobic bacteria are a little slower at decomposing than aerobic bacteria.
Ah,
So that's why you get accumulation of organic matter in wetlands, but it's also a really important component of the landscape too. So
Fascinating.
hopefully that answers Ken's question. And then, can you grow a garden in wood chips? Not very well. And I
Mhm.
will say that I made a really horrible mistake early in my gardening experience. And we had a bunch of sawdust from some project, and we added that to the garden. The problem with adding wood chips or sawdust or anything like that is it's a huge shot of carbon. But what happens is the bacteria you want a carbon and nitrogen ratio balance. And so if you put all carbon, and you kind of outnumber the nitrogen, you're going to suck all of that nitrogen into the decomposition of that carbon source, and there's no nitrogen available for your plant to take up. So if you have a garden and wood chips, you still have to have a nitrogen source that's going to, one, contribute to the breakdown of the wood chips, but secondly, enough nitrogen for the plant you want to grow to actually grow. Because otherwise, all the nitrogen will be used by the microbes to break down the wood chips.
Wow.
So it's not having too much organic matter, it's the wrong ratio of carbon to nitrogen. Now, if people really want to get nerdy, we could do we could do a little sideshow on carbon to nitrogen ratios.
Let's
Let's do
let's do it.
I'm gonna say they might not want that, but we'll see.
I
I
do
don't know
too.
that I'm the
Let's dive
person to do
into
it
like
either.
forest management somehow. How
Right.
about that?
Yeah.
Yeah.
So it's all, there's probably folks on here that listening that know as much or more than I do on carbon and nitrogen ratios. So
Awesome.
Good stuff.
Good
All right.
stuff. Thank you, Dr. Gumbert. We greatly
yeah,
appreciate you.
absolutely.
Always.
Yeah.
She's so good. Yeah.
She is.
Thank you.
She's
Thank you.
awesome.
Thank you.
Thanks for having me.
Yeah. Well, you're always welcome here.
Yeah,
So, yeah. All
definitely.
right. Catch you
Catch
later.
you later. All right. Last year we did the 12 birds of Christmas, but we only found about 6 or so. So Dr. DJ McNeil has found 12 now.
I can't wait to see.
Yeah, so as requested, and I promised you all last year we would do this,
Yeah.
so we're gonna go ahead and play his video of 12 birds of Christmas.
Awesome. All right, we're gonna get it going, folks. We'll drop off. We'll enjoy the video.
All right, folks, welcome to another Wings of Kentucky, our December edition. This is somewhat of a part 2 or an encore, if you will, of our 12 Days of Christmas, which we did last year. And we'll cover some of the same material that we did last year, but also some interesting new stuff that I'm pretty excited to share. So we're going to dive into the 12 Days of Christmas, and it's obvious why we're focusing on a Christmas song, right? It's December, Christmas is right around the corner here. But why that particular song? Well, it's pretty clear, right? There's a few birds in the song, and this is Wings of Kentucky, where we focus on birds. It's also one of the most popular Christmas songs, obviously themed around giving gifts to a beloved partner. It's incredibly repetitive, which annoys me a little bit at times, but a lot of people seem to really love that. The 5 gold rings, right? That's like a big part of the song, kind of the sort of the crown jewel, if you will, although that seems like a rather excessive gift, if you ask me. There's a lot of actual live human beings mentioned in the song. We're going to get to those live human beings in a little bit. But for now, we're going to talk about the large number of birds before we get to the other gifts. So as a reminder of the what we have on the 12 days of Christmas, we've got, of course, our partridge in a pear tree, 2 turtle doves, 3 French hens, 4 calling birds, 5 gold rings, of course, our crown jewel, 6 geese a-laying, 7 swans a-swimming, 8 maids a-milking, 9 ladies dancing, 10 lords a-leaping, 11 pipers piping, and 12 drummers drumming. Now, we're for now going to discuss these 6 here as potential birds, right? Pretty clearly are. So let's dive into these avian components. We're going to discuss the species in the song, or to a certain extent, or take some reasonable shot at doing so. And then we're going to discuss Kentucky counterparts. Okay, so let's first start with that partridge in a pear tree, one of the very lovely parts of the song. If you start looking into what partridge is the species mentioned in the song, there's a lot of controversy here, and actually that's kind of a constant theme throughout the song, is like what it actually means. It's also somewhat unclear why that partridge is itself in a pear tree. And there are versions of it where it's a partridge and a pear tree. So bear that in mind. Oh, let me just adjust my audio here. Okay. So others seem to think that the pear tree might have been added later, but regardless, my digging around seems to indicate that the partridge is probably one of 2 species, either the red-legged partridge, which is this fellow here, or the gray partridge, that one there, which are related to chukars, which are a sort of a partridge, if you will. And we're going to discuss that word in a moment. But it's a very common game bird, as are gray partridge and Hungarian partridge and others. So neither of those 2 partridges are native to North America or Kentucky at all. And we don't need to get too technical, but partridges do not appear to be what's called a monophyletic clade. So that's like a fancy sort of phylogenetics word that means basically the birds that we all call partridge are not each other's closest relatives. So there are other birds that are more closely related to them that we don't call partridges. So it just kind of seems to be a catch-all term for gallinaceous birds that are just sort of fat and plump, which you can arrive at that sort of phenotype through a number of evolutionary means. So what a partridge even is kind of unclear. And many call this lovely bird here, the ruffed grouse, a partridge. And it's one species that we have that's kind of closely related. It's a ground-dwelling game bird or gallinaceous bird. It's quite a bit smaller than your average chicken, although there are some sort of bantam breed chickens that are similar in size to a ruffed grouse. It's found throughout eastern Kentucky in forests that have some kind of like landscape disturbance, or I should say, excuse me, site level disturbance, something that is causing the forest to regenerate, like a wildfire, or beaver disturbance, timber harvesting, things like that. Okay, 2 turtle doves. Now, this one seems relatively straightforward. We've got these doves in the genus Streptopelia, which are very beautiful birds here. These are turtle doves, European turtle doves. It's a very widespread dove genus. We've got, again, that Streptopelia turtur, the European turtle dove, which is a really common backyard dove. They're probably suitable as pets, maybe would be making a good gift. They're also very much edible. And a native species we have in Kentucky that might be sort of the equivalent to the two turtle doves, I would argue, is the mourning dove. It is a small dove, is not in the genus Streptopelia, along with these sort of collared doves like the turtle dove. It's got this little black spot on the cheek here, some black spots on the wings. It's also the only dove we have in Kentucky that has a pointed tail. And it's a very popular game bird. We harvest a lot of mourning doves in Kentucky and across the United States more broadly. And it's a species where we harvest millions and millions of these birds, and their population is doing really robust. And that's because this harvest is what we call compensatory mortality. So there's a certain number of mourning doves that are going to die throughout the winter, no matter what, caused by natural things. And you can essentially skim some of that population off through means like hunting, and everything kind of evens out. Now, if your hunting adds, basically reduces the population by adding to the level of mortality, it's what we call additive mortality, and that's not a good thing. So with mourning doves, hunting is, despite millions of birds being harvested, it's what we call compensatory mortality. It doesn't affect the population in any way, which is a good thing if you want to have lots of them for hunting. Maybe not a good thing if you're trying to control them, because you have to recognize there's a certain number of birds that can be harvested before population starts to decline. With all this mourning dove stuff in mind, we do have a Streptopelia dove here in Kentucky. This is the Eurasian collared dove. So here's that dapper gentleman. Here's our mourning dove, which of course we are more excited about the mourning dove because that's a native dove. The Eurasian collared dove here is, as you might expect, a widespread invasive species. Here's the range map of the Eurasian collared dove. They're significantly paler in color than our mourning dove. They have a squared off tail, and they're also bigger than our mourning dove. Not quite as big as a feral pigeon, but they're quite a large dove and very pale overall. I mean, even just seeing them from a distance, it's like a large pale dove with a squared off tail versus a smaller dark dove with a pointed tail. Makes them pretty easy to tell apart. And of course it has that pigmented nape like so many other Streptopelia doves. So it's got a little black collar on the back. Okay, 3 French hens. As best I can tell, this is one of the more straightforward ones. French may or may not actually refer to France. There are versions of the song that say 3 fat hens. But as best I can tell, this is all Gallus domesticus, which, as we discussed last month, chickens are really just a large, fat, domesticated pheasant. So 3 fat hens might be more appropriate. They're a domesticated pheasant, the wild form of that pheasant being called red jungle fowl. I also found some sources that indicated they weren't actually hens. They were like basically castrated roosters, but maybe that's a little too into the weeds first. We discussed also last month on the sort of Thanksgiving episode that the chicken, contrary to popular belief, is not the first domesticated bird species, but it has been domesticated for about 5,000 years. The first domesticated bird species being the feral pigeon, or the pigeon, which has been domesticated for twice as long as the chicken. Now, one species we have here in Kentucky that, if we want to stretch our imaginations just a hair, to be similar to our little chicken, our 3 French hen, might be the northern bobwhite, Calinus virginianus. So Gallus, the red jungle fowl, is an Asian species. So we have this cute little New World quail, the northern bobwhite. Now these are very different from the Old World quails, like the genus Coturnix, like the Japanese quail. And these bobwhites are very social birds. They live in small flocks in the winter that we call coveys. They're named for the whistling songs produced by the male. So the male will get up on a prominent perch and he'll stick his breast out and tilt his head way back and go bobwhite with a really nice clear whistle. And bobwhites are doing poorly just across the map. They're grassland-dependent species and declining rapidly. So, and they have been for almost 100 years. And bobwhite populations continue to disappear. Whoa, alarm on my phone. Continue to disappear from parts of their range. 4 calling birds. So this one was kind of interesting, to be honest with you. Apparently, it's not supposed to be calling bird. It's supposed to be collie bird. And I did a little bit of digging here. Collie, the origin of that word here is a little bit messy. It could be the same origin as the dog collie. But either way, it seems to be that a collie bird is a Eurasian blackbird, which is this dapper fellow here. Really cool little bird. It's a thrush in the family Turdidae. It's got this overall black plumage. It's got this yellow beak and a yellow eye ring. It's beautiful. Turdus merula. And you'll notice that it bears a striking resemblance to our American robin with black plumage. In fact, Turdus merula, it's in the same genus as our American robin, Turdus migratorius. So there's our Turdus migratorius. We're going to call that our collie bird for today. And we've discussed it numerous times on Wings of Kentucky. It's in the Turdidae, the thrush family, spending a lot of time on the ground. It's a year-round resident here. And we're currently in the non-breeding season, when we're in this time of year, these robins, they tend to form small or large flocks. I mean, I was seeing small groups of like 4 or 5 in my yard yesterday. And I hear like very small population or small flocks, let's say here around campus in Lexington. But sometimes they can form flocks of a few hundred birds or more, where they seek fruits and invertebrates and things like that. Okay, moving along, 6 geese a laying. As best I can tell, this is another one that's fairly straightforward, probably the domestic gray lag goose, Anser domesticus. And these are a really large-bodied goose. You'd also call it like a heavy-bodied goose. It's very like round. It's got a very deep belly on it. And in its domesticated form, many of the adults cannot fly, although there's some definitely can. They're really long-lived birds. If they're cared for well on the farm, they can live for decades. In a barnyard setting, they're kind of known for being fairly aggressive and territorial, but also really smart. They're pretty interesting birds. And their eggs are certainly edible. It's a geese laying, right? But I would say that in my experience, keeping geese for edible eggs is somewhat uncommon. They're not super prolific layers, but they do lay larger eggs than things like ducks and chickens. So there's something to that. And of course, we have our Kentucky counterpart, would be the Canada goose. At least that's what I'm going to define it as, Branta canadensis. Now, this bird is, a lot of people have problems with them. They can achieve really huge population densities, and they occur in areas frequently that have a lot of open grass, which means people want to walk around there, and the geese are pooping all over the place, maybe causing human-wildlife conflict, attacking people because they're very territorial. Despite those shortcomings, I think they're pretty cool birds. I mean, they feed mostly on grass. Geese kind of do that in general, but I mean, that's honestly remarkable. There are very few birds that feed largely on grass. In fact, even like swans and other like sort of small waterfowl like ducks, they might be able to eat some vegetation, maybe even some grass, but they can't live on grass, whereas geese basically can just graze and get all their nutrition from grass. They also mate for life. So if the male and female pretty much are together all the time. If something happens to one of them, they'll remate. But by and large, they stick together. Highly migratory, long-lived. They can live for decades. And at one point, Canada goose populations in the United States declined so much that conservation actions were needed to recover their populations. And that work has been done. And that these birds are now so abundant that they're sometimes a nuisance. And of course, they can hybridize with other geese, including domestic gray lag geese, which is somewhat remarkable given that they're in a different genus. Okay, 7 swans a swimming. The mute swan is the species we're going to assume that this is. Now, this is a European species. It's not quite mute, but it really doesn't make a lot of noise, to be totally honest. They hold their wings kind of in this upright posture like this, which is very beautiful. They have this orange bill with this like black knob, as it's often called, sort of a fleshy black protrusion. It's an invasive species in the US, and a lot like Canada geese, they do kind of mate for life, as it were. But again, unlike geese, they do not feed all that much on grass, mostly aquatic vegetation and grains and things like that. Now, one tricky thing about this species is is it's been implicated as a competitor for our native waterfowl like Canada geese and other native swans, which we're going to talk about in a moment, as well as ducks. And I dove into the literature a little bit on this topic, and it seems to be somewhat controversial to what extent mute swans compete with other waterfowl. And because it's not native, in some states they're a huntable species, and in others they're totally protected. It's kind of an interesting issue. So our native equivalent is going to be the trumpeter swan. It is one of our two native swan species, with the trumpeter swan looking very similar to the tundra swan and being much larger than the tundra swan. And our trumpeter swan has a solid black bill, as you can see here, with no black knob bulging from the forehead. It never holds its wings kind of raised like a mute swan does. And otherwise, many other aspects of their life history, like mating for life and so forth, are similar to mute swans. And these things are huge, like they're easily 40 pounds. It is our heaviest native bird here in Kentucky. Very protective of their young. A male swan, often called a cob, is very protective of the young, which a young swan is called a cygnet. Okay, so what about these non-birds? There's some golden rings. There's a lot of people. Well, we did a little bit of digging on this. The 5 gold rings, the maids a milking, ladies dancing, lords a leaping, pipers piping, and drummers drumming. It seems fairly likely that these are also birds. Or at least we're going to embrace that theory here. I wouldn't necessarily bet my life on it, but I'm going to roll with it here based on some of our digging. And there seems to be a theme of these birds that we've already covered, and the birds that we're going to discuss for these gold rings and etc. These birds are all edible. So more than likely, this is a song about birds that you might be eating around the holiday. So keeping in our Thanksgiving style theme. So the golden rings. Now, we talked a little bit about this last time. There seems to be a bit of a mess here. Some of the early versions of the song clearly depict actual rings, but there's other versions of the song, depending on which language it was translated for, that it was either a golden pheasant, sometimes a golden ringed pheasant. I've also seen it described as a ring-necked pheasant, which is one of the exotic species we've introduced to the US, or even the European goldfinch. But if these are edible birds, I would think the pheasants, probably the ring-necked pheasant, which is widespread in Europe, would probably be the golden ring, if you will. Now, maids a milking, you're like, dude, all right, how are you going to tell me that maids a milking are a bird? And again, we're sort of having a bit of fun with this, but I think it's a reasonable hypothesis. And two potential birds would be the cattle egret and the European nightjar. So the cattle egret is famously named because it spends a lot of time around cows. And the reason it does this is it follows behind cattle or other large mammals. The species occurs in Africa, where it follows things like elephants around as well, even hitching a ride on their back sometimes. And it does this because these large animals like cows and elephants and what have you are going to kick up insects like grasshoppers for them to eat. Certainly could be argued that this is a maid a milking, if you will. Another species would be the European nightjar. Now, this is a very bizarre looking bird. They're in this sort of like nightjar and nighthawk family. And nightjars, the other nickname for nightjars are the goat suckers. And the reason for this is it was once thought, and this is a very old idea, now it's been proven false. But an old idea was that these birds used to fly into the milk barn and actually suckle from the udders of goats, which gives them the name goat sucker. So, and you'll still see them referred to as goat suckers in a lot of the bird books, even today. So potentially our maids a milking are some species of bird. If it was something that is actually milking, I might say the European nightjar, but if we're talking about something edible, I would rather eat the cattle egret myself, quite a bit bigger, easier to find, many of them, etc. Okay, our ladies dancing. We've got a variety of different European birds where this song originated that would have been large and would have done some dancing. One of those being the great cormorant. They do not only do they do a sort of a dance to attract a mate, but Like many cormorants, they stand with their wings spread out. And our Kentucky version of this would be the double-crested cormorant. They stand with their wings open after they've dived down into the water. They feed primarily on fish, and they let the sun and the air dry their wings, so they sort of dance, if you will. Now, there's also the common crane, which is not unlike our sandhill crane we have here in Kentucky, which cranes are famous for dancing. In fact, the male and the female will form a pair together, and they also do this mating for life thing that a lot of these large water birds do. And they famous for like almost literally dancing. It's not fully understood why they do this, but probably some kind of greeting between the male and the female, reinforcing the pair bonds, where they'll jump around and throw their head back and flap their wings and will actually do a somewhat of a dance. And our sandhill cranes do the same thing. Now we're thinking about these birds in terms of eating them. The sandhill crane is often hunted throughout parts of the United States and known as the sirloin of the skies. So they are a delicious bird. Lords a leaping. So some sources that I was digging around in suggested that this may refer to either the gray heron, well, probably referred to the gray heron. Now, we, of course, have our Kentucky version, the great blue heron, as likely a species that would have been called a lord a leaping, and that would have been pretty edible. Apparently, you want to be careful when you're cooking these things, which, of course, is illegal. But if you were going to, as a medieval peasant, you apparently want to avoid breaking the leg bones or any of the bones in there because they contain a really disgusting marrow, the more you know. Piper's piping. I don't think it requires too much imagination to think that this could be some kind of sandpiper. And two sandpipers that come to my mind would be well, they're equivalent for us, the Eurasian woodcock, which is this guy, or our version here, the American woodcock, which is even today in the United States, a very heavily sought after game bird. Finally, drummers drumming. Now, I've seen a couple different arguments for what this is. Some people argue that it's a snipe, which produces a drumming call, but I think a more palatable drummer might be a woodpecker, right? These guys are well known for this behavior. We're going to point out a European species that probably is widely consumed back in the day, the great spotted woodpecker, which is very similar to our own hairy woodpecker. And with that, we'll leave it at that. Merry Christmas to you all. Thanks for tuning in to another Wings of Kentucky. Look forward to seeing you after the new year. And Merry Christmas.
Well, we always appreciate Dr. DJ McNeil doing those. They are always awesome to be able to see, and especially all these 12 days of Christmas, 12 birds of Christmas, I guess we could say they are. So we greatly appreciate you joining us too every week. We are in the Christmas season, so we will have some Christmas shows coming up in the next couple of weeks as well, including Christmas trees and things like that. But if you have any suggestions whatsoever, you can go to fromthewoodstoday.com and we will have a little survey there, and you can click on that and take that survey and give us any suggestions that you might have. Also, you could email those to forestry.extension@uky.edu, and I can get them that way. That goes straight to my email, and we can be able to handle them, get that taken care of. But again, we greatly appreciate you joining us because we wouldn't have the show if it wasn't for you. So send us those ideas if you do have any. And then, so we're up on our time, so we will go ahead and end for today, but we will see you next week at 11 o'clock. Take care. Bye-bye.
From the woods today. From the woods today.